This is a session on getting started with infrastructure as code and Terraform. My name is Quinn Snyder. I'm a technical advocate with Cisco Learning and Certifications at Q Snyder and all the socials. But this is really an introductory, a real basic primer into what Terraform is, why it was developed, what we can use it for, and some real basic syntax. So if you've been professionally exposed to Terraform, if you have used it in a lab or even in production, it's probably a little bit beneath your level, but there may be some tips and tricks that you can learn through this. So if there's any questions, feel free to find me afterwards. I'll be around this booth and the DevNet zone as well to answer any questions. So with that, we'll go ahead and get started. I want to do a quick introduction and background of what Terraform is, how it was developed, what the pros and cons of using it are, talk about a typical workflow that you would follow when developing your configuration inside of Terraform, talk about the HCL syntax, which is the HashiCorp Configuration Language, and show some basic configuration and some programmatic control options that you have. And then I really want to get into a hands-on demo so you can actually see what Terraform looks like when you implement it, and then we'll do a wrap-up with a raffle as well. So Terraform was created in 2014 by HashiCorp, and it was originally made as an IAC, or Infrastructure as Code tool, for cloud providers. A lot of ClickOps, if you've been in the AWS control panel or Azure or GCP. The main focus of Terraform was really to scaffold or create the infrastructure inside of those cloud providers. However, since then, it has evolved to be kind of a full data center management orchestration tool, really with the kind of the push from on-prem infrastructure providers to build APIs into their products. So when you look at Terraform in general, it is written in Go, which is it creates a single binary file. So unlike things like Ansible, where we have to pip install or we have all those dependencies, you download a single binary file from the HashiCorp website, install it into your path, and you're ready to start rocking and rolling with Terraform. I mention that it is compiled in Go for two reasons. One, because it is compiled, it does create that single binary, and there's no real upgrade path. You simply download the new version and replace it. There are management tools like tfenv, if you're familiar with PyEnv or some other Python tool management, very similar in construct, but there is no real upgrade path beyond that. You have to download the new file. The second reason I mention that is that there is no native SSH library for Go. Carl Montanari, who works at, I believe he's still at Twitch, has created Scraply Go, which is a Scraply implementation in Golang, but that will not be adopted, as best I can tell, into the Terraform upstream. So the only way that you can use Terraform is if your infrastructure has REST APIs. So REST API only for Terraform. That does include a lot of your controllers, so ACI, NDO, NDFC, SD-WAN, DNAC, secure workload. All of those have REST APIs exposed northbound that we can use with Terraform, but there is no device-by-device configuration that we would get with like Paramiko or NetMiko with Ansible. So that is kind of a drawback, and that's why I mentioned that it was written in Go. The other part about Terraform, it is fully end-state declarative. Now, I mention end-state specifically because, unlike other IAC tools, Terraform does not care in what order you build your configuration. And I'll show an example of what I mean, but it doesn't matter if we put things out of order. Terraform will automatically build those resources in the correct order on your infrastructure via its circular dependency graph that creates as part of a provider. So it's end state declarative. Nothing is worried about in the middle. You write what you want at the end of the configuration. A typical Terraform workflow, like I said, you want to download and unzip the binary, install that in your path or in your local folder. Then you write the configuration that you want to apply in HashiCorp Configuration Language, HCL. We'll touch on a little bit what that looks like and why it's not so scary, even though it kind of has a lot of curly braces. It's nothing to worry about. You'll then run a Terraform init. So Terraform is only one part of the equation. You need to have a provider. That provider, it gives Terraform the information that it needs in order to connect to the infrastructure that you want to configure. very similar to an Ansible collection, if I can draw that analogy. But the provider is there, and that's what tells Terraform what the APIs are, what those endpoints are, what the data looks like, how I structure that data, and how I can parse that data and get the output that I need. So that provider is very important, and I download that from the Terraform registry with Terraform init. The second step is the Terraform plan. The plan looks at what my configuration file is, what exists on the infrastructure, and says, how do I get from point A to point B? What's new? What needs to be deleted? What needs to be created? All those kinds of steps. Finally, we do a Terraform apply, and that takes the information that was generated from that plan and actually configures the infrastructure. Now, the other really cool piece about Terraform is that I get this destroy action for free. Unlike other IAC tools where I have to not only know what order I go forward, but how I need to roll back, Terraform is stateful. Terraform tracks the state of my infrastructure pre and post change within its project and says, if I need to roll this back with a destroy action, I've already got that state saved. I know what existed beforehand. So by doing a Terraform destroy, it says, do those things still exist on the infrastructure? Okay. Has the plan changed? Okay. Now let's remove it. So you go forwards and backwards very easily. Now, the downside to this, and what I don't know if I'll have time to illustrate it fully, is that Terraform is generally used in the context of immutable infrastructure, things that don't change. If we look at something, and I hate to keep using the Ansible reference, but Ansible does drift. I have a device at state A. I need to move it to state B. I only do a diff of changes between A and B. Terraform does not do that. Terraform says, I have state A. I want to move to state B. I'm going to rip out A and put in B. So that does have production level implications if not done correctly. But it has to track the state in order to do that. But we get the destroy action for free. So again, pros and cons. It's not an either or. It's a what's right for your environment and your infrastructure. HCL. So HCL, HashiCorp Configuration Language, is actually pretty simple. If you're used to reading JSON payloads, you get arguments and blocks. Arguments are highlighted in yellow, where it's a simple assignment, just as we would with any programming language. A block is curly brace delimited, so you can see that we have this resource ACI tenant. So I'm creating a tenant within ACI. I've given it a locally significant name, and I've bounded it by a curly brace. In that block, in that block, I've got a name for the tenant and a description. So they can be done using static assignments, or in this case, that var dot prefix says look for a variable called this name, and we'll get on that in a little bit. It is possible to read in configuration as well. So if you look at the documentation on the Terraform registry, you'll see data sources and resources. Data sources read in config that exist already on the device that I want to use later. Resources create the configuration. Let's see. Probably the most difficult part about Terraform, besides the number of curly braces, is the dotted notation. So follow me on this journey. Without knowing what a schema is inside of MSO, I've created one and given it a name, schema object. So MSO schema is something that I would configure in MSO, and I've given it a name called schema object. In that block, I have a name of the template for that schema. If I need to reference that later on, I just nest through it, kind of similar to what I would do if I'm iterating through Python classes. I use that dotted notation. So MSO schema, so that says look for all resources called MSO schema. Look for something called schema object, so I found that specific instance of the schema, and then look for something called template name inside of that. So I'm just using a dotted reference to nest back where I need to look for. And finally, there will be things that get exposed as part of a Terraform run. Generally, it's an ID value. Just think of that as like a unique UUID per each instance, so I don't need to reference or call out the name specifically every single time. I can reference that ID value. It is possible to do programmatic things like looping with Terraform. And in this case, I have this variable called switches. Inside of this variable switches, you can see it's curly brace delimited all the way down to the bottom. So this entire map is the variable. I've got a set of information in a list almost. So I've got this spine 1, spine 2, leaf 1, leaf 2, etc. So I have these all defined within this map. If I wanted to iterate and add each of those devices to an inventory, say of Nexus Dashboard Fabric Controller, I just use the for each. So for each item in this variable called switches, so inside of that map, I need to iterate over each of the value, or each of the items, so each of the top level, spine 1, spine 2, leaf 1, etc., and pull out the value of the IP and the value of the role, and insert those into my top level control. So I'm nesting through each item in the list, pulling the data out in the key value pairs, and putting the value into that assignment block. So we can do basic looping just as we would with things like Ansible. So with that, I want to jump into the demo. I'm sorry, what? Well, because I'm sharing my screen here.
Right now, but we were seeing it in presentation.
Oh. Yeah. Am I good? Yeah, okay. Sorry. Okay. Sorry about that. So nothing up behind the scenes here. All I'm doing is using the reservable ACI sandbox through DevNet Sandbox, and I have some code here. So we see we have no tenants created besides what exists beyond the standard setup. And I have a list of code here. I'm only going to get to probably 2 or 3 of these, but I'm going to start off with this very basic main.tf file in the 01 folder. At the top, I've declared the provider that I need to use. So I'm using the ACI provider. I need to use that to connect to the end resource, which is this ACI simulator that sits inside of the sandbox. When I do a Terraform init inside of the folder, it's going to reach out, grab the latest version, because I have not defined a version. You can actually lock it to a version if you so choose. It's going to download that provider from GitHub and install it, and then perform a key check to make sure that the provider that I downloaded matches with what's given in the registry. So we have a little bit of a check there, so there's no man in the middle possibilities. We see green. Terraform's been successfully initialized. Now I have the tools available inside of this folder, inside of this project, to be able to configure the ACI fabric. The second part of this is defining how I need to connect to that provider. In this case, the username and password, the URL that I'm using to connect to, that's the 10.10.2014, and then insecure equals true because I'm not doing any certificate validation because this is a lab and I can get away with it. The last piece of this is something very simple. I'm just creating a Terraform tenant. Even if you, or sorry, an ACI tenant. Even if you don't know anything about ACI, a tenant's a very simple construct. It's just a place to hold a variety of different configurations from applications and network pieces, but it's that top level container, if you will. I've created, I'm going to call it QMS tenant 01 with a description of Cisco U demo tenant. So let's do a Terraform, if I can type Terraform plan. By running this command, Terraform says, okay, I see the configuration. I'm going to pull that all together as I need to. I'm going to look at the infrastructure and say, oh, it doesn't have this tenant currently. So I'm going to create these resources as denoted by the green plus. So it knows these need to be created. It's pulled in the information like the tenant name and the description. These other things like the ID or a name alias can be added if I chose to. Some of the known after reply says I'm going to accept the defaults as they're given to me. If everything is good, I can do a Terraform apply. And just doing a Terraform apply, because I haven't followed a few best practices, it's going to say, hey, do you really want to apply this? Kind of a Windows next screen. Are you sure you really want to do this? I accept the risk, and I'm going to type yes. And it's going to reach out and create that tenant inside of ACI. Now, the nice thing of it is it's going to, as of the newer versions of Terraform, it's going to tag with an orchestrator tag that says that this tenant was created with Terraform, so that you know that there's something outside of the UI that created this, and therefore you should take caution if you're going to edit it manually through the UI. So we've just created our first tenant. Expanding on this just a little bit, we can look at something using variables. And I will go into this other folder and do a Terraform init. So this main.tf file looks very similar to what I had before. I'm still having to define the required providers. Each folder, I should make a note of that here, each folder inside of this Terraform will treat each folder like a project. So if these folders were nested, it would mash all of that Terraform file up together. Because they're all on the same level, it treats them as individual projects. So be aware that a top-level folder will be treated as an individual project inside of Terraform. So this 0.2 looks very similar to what we had before in 0.1. I've defined the provider. I have to re-download it because I'm in a separate project. But what I've done here is I've taken the username, password, and URL of the ACI fabric, and I've abstracted that away into a variables file. So var.user, var.password, and var.user.url. Likewise, I've done the same thing for a tenant, var.tenant. So what I will do now is open up this variables folder file and show how this gets mashed up together. If we look at the top piece here, the connection type, var user username. Var says look for something denoted as a variable type, which means it's not a provider type, it's not a resource type. Look for a variable type. So we have this type variable right here. The variable name is called user. So look for a variable called user, which we have here. And then inside of that map, I have username, password, and URL. So I've just nested through that in dotted notation. I'm looking for all these things based on how I've written the TF code. Second, again, looking for the variable.tenant. We have this variable called tenant, and it has this default name of QMS tenant 02. Now, when I do a Terraform plan here, I don't need to tell Terraform to say, look at this file, or look at this file, or look at this folder. Terraform will take every single HCL file in that folder and mash it up. It doesn't matter if I've called the file variables.tf or user.tf or tenant.tf. It could have been called anything. Terraform takes all those HCL files, brings them all together, and then that's what generates the output plan. So that's when I say when it treats a folder as a project, be aware of that, because if you put things in the wrong places, you could have a bad time. And like you can see here that it found, we can't see the connection type, but you can see that it found that QMS tenant 02 from that variables.tf, put it into the plan, and when we do a Terraform apply, yes, I want to apply it. It will create that tenant, and it has given that name that we defined in the variables file. So pretty cool at this point. I'm going to skip ahead a little bit and talk about something a little bit more in depth when it comes to what I mean by end state declarative, because that could be a little bit of a difficult concept to wrap your head around. So I'm going to go to this network folder and look at the main.tf. Let me make sure I'm not getting confused here. And the variables.tf. So in this main.tf, I'm going to take a little bit more configuration and apply it. I still have the required provider. I still have how I connect to that provider. I still have a tenant, but in this case, I'm also adding a VRF, a bridge domain, and a subnet to my configuration. So you may not know anything about ACI, but at a high level, a tenant houses a VRF, which houses a bridge domain, which houses a subnet. It must be created in that order if we're doing things manually through the UI or through a tool like Ansible. Otherwise, it will fail because there are linkages between those objects. In fact, we can see that in the configuration here. Just for example, the bridge domain. Inside of that bridge domain resource, what is the relation to the context or the VRF? And it's given by that ID value of the VRF that we create. So it's linking all these things together, but normally we would do that in Ansible by putting it in the right order. I have this in the right order just by chance here, and we'll go ahead and we will go into that folder, 05 network. You get really good at typing Terraform, by the way, using this. Let's do a Terraform plan. And we'll do a Terraform apply. I'm going to cheat a little bit. You can do a flag called auto approve. The flags in Terraform are only single dash, not double dash. So thank you for eschewing standard POSIX rules. So it's only a single dash, not a double. But we'll auto approve, and we won't get prompted to create or prompted to type yes. So you can see there's 4 things that needed to add. It's creating the tenant, creating the VRF, creating the bridge domain, creating the subnet. And if we go into this 05, which just appeared, little slow. Come on, I know you can do it. There we go. If we go under networking and look at VRFs, we can see that VRF was created, and the bridge domain will have a subnet underneath it. So all of those things have been created just like Terraform said they were. Great. But we would expect that to work because it was in the right order. Let's go back, and I have this unordered folder, and we'll close both of those items. We'll go into 06, and we'll look at main, and we'll look at variables.tf. Close that up. So this main TF has the same guts inside of it, more or less. I have the required provider. I have that username and password and how to connect to the fabric. But you can see my first item is the bridge domain. My second item is the subnet. So, okay, maybe that'll work a little bit. But the VRF and the tenant that house those bridge domain and subnet are at the very bottom. In other IAC tools, this would fail. And we would have to revert or roll back in some way, maybe build it into our playbooks, figure out where it failed, how it failed, do the checks, roll it back automatically, and then we'd have to put it in the right order. Let's see what Terraform does. So we'll do a Terraform init. Download that provider. We're going to do a Terraform plan. Okay. Everything worked. Maybe it's just, okay, maybe it's not actually checking the infrastructure. Maybe it just says, okay, we're going to create all these things, but it doesn't know how to do it in the right order. Let's do a Terraform apply. And I will do the auto approve. Same thing, 4 is going to be added, but you can see it creates the tenant, the VRF, the bridge domain, and the subnet in that order. The same way it did for the ordered file that we had before. Okay, just to show that there is absolutely nothing up my sleeve, because Rocky and Bullwinkle is totally relevant at this day and age. Let me go back. Come on. Don't make a liar out of me. All tenants. 06. And under networking, nope, not application profiles, networking, where you can see we have the bridge domain, the subnet was created, we have the VRF, and yes, I did not show the full variables file, but you can see that we created the tenant 06, and those are the names that line up and the subnets that line up. That's what I mean when I say end state declarative. It didn't matter what order I wrote that Terraform configuration file in. Terraform builds a circular dependency graph that's based on how the providers work and what the providers require, and institutes those resources and those configuration items in that exact order. In fact, we can query this. So I have a command here. You can query the Terraform graph by using the Terraform graph command. Now, the rest of this is just fancy to get it out of the dot file and turn it into a PNG, and I'm going to name it tfgraph.ping. So if I do a cat graph command pipe to bash, and we should see that we have this tfgraph.png file, and I will find a way to make this bigger. Let me scroll this over a little bit. Let me zoom in. So even if you know nothing about the ACI MIT, even if you know nothing about how the topology tree is generated, this should look pretty familiar to what was applied. We have a tenant with a VRF, a bridge domain, and a subnet, and they're all related in that order. And I ran this command by querying the graph that was created from the unordered configuration. So Terraform understands the correct order to apply it, so I only need to worry about what gets created, or what the end state looks like, not what's actually in there. So with that, that is the end of my demo and presentation.